Welcome back to the Astronomy Outreach Group's video series. Today we are going to discuss how you would distinguish a satellite or the International Space Station from the celestial background. In other words, what we want to talk about is how do you decide if something is a satellite or if it's a planet or a star or something else completely. In order to talk about how we find things like this or how we distinguish between stars and satellites, we need to talk about the devices that we use to see them. And since most people don't have access to telescopes or direct access to telescopes from home, we're going to use our eyes as devices to see these things. In order to use our eyes, we need to understand the limitations of our eyes. So our eyes are magnitude-limited devices, and what that means is that there is a magnitude limit or a brightness limit after which we can no longer see. So for the human eye, that tends to be at +6 on this crazy backwards magnitude scale. So in astronomy, we use a magnitude scale that looks a little weird. 0 is in the middle, and then we have negative numbers on one side, which means that things are super bright. So for example, the sun is at -26, and then we have positive numbers on the other side, which are super dim. So something like the Hubble Space Telescope is at like +32 or something like that. And so we have this range of objects of various brightness, but we can also figure out where on that range our eye can actually see. What kinds of objects can our eye see? And the magnitude limit for us is +6. So anything that is above +6 or above the naked eye limit mark, we can see. So we can see Polaris, we can see Venus and other planets, we can see the full moon, and we can see the sun. But it's really hard with just your eye to see Pluto, even at its maximum brightness. And that's just because we are limited to the devices that we have. So now that we understand the limitations of our eye, we can talk about finding things in the sky. We can talk about what to look for when you're looking for a satellite. So it's actually really hard to find satellites. The reason it's really hard to find satellites is because there are hundreds of them that we will never see because our eyes are not sharp enough, or they can't see that magnitude. And there are hundreds of them that we can see, but we're really bad at being patient and sitting still. So in order to actually find satellites, you're going to need to be patient and sit very still. If I were to go out and do this, I would find a place in the grass and I would lay down and I would just lay there and stare at the sky. We would do this for two reasons. One, I'm not moving relative to the Earth. I'm laying down so I can't wiggle back and forth. And two, I need time for my eyes to adjust so I can actually see magnitudes that are that dim. If you look at your phone screen or some other type of bright light prior to looking up at the sky, it's going to look pretty washed out just because your eye has to reset itself to actually be able to see that brightness. The other thing you're going to look for is something that's moving differently. So the apparent motion of things on the celestial sphere is follows that of the Earth. So the stars look like they rotate, they look like they rise and set because the Earth rotates. However, satellites don't do the same. They rotate independent of the background, so they look like they travel differently. So you can see all of the stars moving very slowly over time. If you watch the night sky, what you would see if you looked for a satellite then would be something moving much quicker. So we can look for changes in speed to highlight satellites. Sadly, we can't see them all, and that's okay. If we're going to see a satellite, we need to meet a few criteria. They need to be large enough, they need to be at least 20 feet in length or width or whatever the dimension is, and they need to be low enough. They need to be about 100 to 400 miles off the surface of the Earth. Anything lower than that we can definitely see. Anything higher than that or smaller than that, we struggle because of the magnitude limits. Alright, so what satellites can we see? Well, we can see the Hubble Space Telescope, which is the one shown on the left. We can also see the Starlink satellites, which are shown on the right. Both of these satellites are visible from Earth at different points in time. So for example, if you're going to look for the Hubble Space Telescope, you would want to look super early in the morning or super early in the evening. So right before sunset or right after sunset, because generally this telescope is not as bright as the Starlink telescopes are, or the Starlink satellites are. So depending on the size, how far away, you're going to change when you view these things. And these are just a few. In the video, we will link a satellite finder, so you can go ahead and track the different satellites that you want to find, or track patterns of the International Space Station or the Hubble Space Telescope, or any of the satellites that are bright enough for you to see. So that's just a few of them. I've mentioned the International Space Station a few times, so I'll go ahead and actually talk about it. The International Space Station is fairly large. It's about the size of a soccer field, and it is about 250 miles off the surface of the Earth in a low Earth orbit, meaning that we can see this satellite. It is very bright in the sky. That being said, it moves really quickly, so if you miss it at one point in time, you can, in the same day, go ahead and still find it. So the International Space Station is about the size of a football field, 250 miles above the surface of the Earth, and it completes one full orbit of the Earth every 90 minutes. So it travels at about 5 miles per second. And its magnitude brightness is -6, which means that it's 12 steps from what our eye can see. So it's actually really bright for a satellite, and that has to do with its size and its close orbit. So what does it look like in the sky? If you were using a naked eye measurement, what you would see in the sky is some sort of streak that's shown on the left. It kind of looks like a shooting star almost, and this image was taken with long exposures, so you shouldn't expect to see a streak going through the sky. But you would be able to see that path being traced up by the space station. If you were to use a telescope or some sort of advanced device that enhances your eyes' viewing, then you should expect to see what's on the right. You would see some sort of solar panel structure and a large silvery bar in the middle. So go ahead and give this a try this weekend if you can. The best time to view satellites is early in the morning, right before sunset, or early in the evening, just after sunset, in the summer. And the reason why is because we have super long days, and so the sun setting takes a really long time, and the sun rising takes a really long time. And so we have these long periods of dark background, but bright enough that it's washed out all of the extra stars, so we don't have to see all of that cluttering the view. And we can just see the satellites streaming by. So go ahead and give it a try. If you have found a satellite before and you want to mention it in the comments, feel free to do that. Otherwise, happy sky hunting, and we'll see you back here next time.